In this video, we will learn how to predict chemical products. You should know by this point that how to identify types of reactions, balance reactions, and write balanced chemical formulas. Remember in our last video, we figured out how to balance reactions based on coefficients and counting them all up. You should know how to do this by this point. Steps to predicting products. First, you have to identify the reaction and the type of reaction. Write correct chemical formulas for the products. Okay, let's jump into some practice problems. So in this reaction, we've got sulfuric acid plus sodium hydroxide that forms something. First thing we need to do is figure out the type of reaction. So if we split these apart like we did in the other video, this is AB plus CD. And then you should figure out from that looks like a double replacement reaction, and it is. So then our products from a double replacement reaction will be AD plus CB. So now that we know what type of reaction we have, we can start writing the chemical formulas. So A and D come together to form H. A is H, D is OH, plus C, which is sodium, and B, which is sulfate. Now what I like to do is figure out what charges these things have so I can know if these are balanced or not. So hydrogen's gonna have a +1 charge, hydroxide's gonna have a -1 charge, so that's all good and dandy. So they'll actually balance each other out and become water. Then sodium has a +1 charge, sulfate, if you remember, has a -2 charge. Therefore, I'll need 2 sodium atoms to counteract the charges from the sulfate. So that'll be Na2SO4. Now we can kind of bring this down. NaOH, H2SO4. And now we can actually start to balance the reaction. So again, if you remember how we balance reactions, we make sure everything is balanced, all the formulas are balanced, which they are. We draw a line down the center, and we start counting up all the elements. So we've got hydrogen, sulfur, oxygen, and sodium, and we can write the same on this side. We got 3 hydrogens over here, 1 sulfur, 5 oxygens, and 1 sodium. Over here we have 2 hydrogens, 1 sulfur, 5 oxygens, and 2 sodiums. So again, we can balance this reaction. We can see that if we put a 2 there, we can balance the sodiums, which changes the oxygens to 6, changes the hydrogens to a 4, and then all we need to do is put a 2 there, which changes that to a 4 and changes the oxygen to a 6. So there we are, we're balanced. All right, let's try another one. So this one, we have iron 3 chloride that reacts with magnesium oxide to form something. Again, if we split these up, A, B, C, D, this is another double replacement. So we've got, again, it'll be AD plus CB, which means we can start writing formulas, or at least placing the atoms where they're going to go. So this will be Fe and oxygen plus magnesium and chlorine. Again, we need to figure out the charges. So iron is a transition metal, which means that you need to figure out what it's bonded to in order to see what the charge is. So this is iron 3, so that's going to be a +3 charge. Oxygen has a -2 charge, so that means this will be Fe2O3. Magnesium has a +2 charge, chlorine -1, so that's MgCl2. We can yield this around. Again, write the reactants down so we have a nice even reaction, and now we can balance it. Draw the line. We got Fe, Cl, Mg, and O. Now we can start to count them all out. That's 1, 3, 1, 1, 2, 2, 1, 3. First thing I would balance is the irons because it seems like that's a little simple. So we've got a 2 there, which changes that to a 2 and also changes this to a 6. So then we'll need a... Next thing we can balance is the chlorines, which means we need a 3 here. Changes that to a 3. Changes this to a 6. Good, good. Now we can change this. Mg3, O3, and now we're balanced. Okay, so here we are on a third practice problem. This one's not too difficult, so why don't you try to pause the video, figure it out, and then come back when you're done. Okay, so you should be done with this. Let's walk through it. This is A plus B, which is synthesis. So that means we're going to be yielding AB, which means our formulas will be magnesium oxide, which is Mg and then O. Now remember, magnesium and oxygen both have +2 and -2 charges respectively. So that is a balanced reaction, or a balanced equation. So then we need to balance the reaction. Draw a line, MgO, MgO. We've got 1, 2, 1, 1. We can put a 2 there, changes both of these to a 2, and then put a 2 there, and we're balanced. All right, so here's our fourth and final practice problem. This one might look a little bit more difficult to you because we've got polyatomic ions here. Remember, they act the same in a chemical reaction, so they're gonna move together. So first step, as always, figure out what type of reaction it is. So in this case, we can split it up there and there, which is another double replacement reaction. So we know that it's going to be AD plus CB. When we write these things out, the lead is going to come over first, Pb. D is nitrate, NO3, plus sodium and phosphate. So again, lead is a transition metal, which means we need to figure out what it's bonded to and the charges of that, so we can figure out the charge of the lead. So if we see phosphate, it's got a 2 right here, which means that 2 came from over here, so that's lead 2 phosphate, so that's gonna be a +2. Nitrate, as you know, has a -1 charge, so that means we're going to have Pb, parentheses, NO3, 2, plus, and then sodium has a +1 charge, phosphate has a -3 charge, so that's gonna be Na3PO4. We can copy all these things down, so we can have a nice, fresh place to balance. All right, so now we need to balance the reaction. We got this, draw a line, Pb, then phosphorus, oxygen, sodium, and nitrogen. Pb, phosphorus, oxygen, sodium, and nitrogen. We've got 3 phosphorus, 2 phosphorus, then 6 over here, plus the 3 is 9, 1 sodium, and 1 nitrogen. Then over here we've got 1 lead, 1 phosphorus there. We've got 6 over there. 6 plus 4 is 10 oxygens on this side, 3 sodiums, and 2 nitrogens. Now this might look really confusing, but you can also see that nitrate has 2 over here, and lead has 3 over there. So in order to balance this out, we have to kind of look at it that way. So let's balance the leads first. That means I need to put a 3 here, changes that to a 3, but it also changes a lot of other stuff. So sodium or nitrogen here will be 6 because 2 times 3 is 6. Then the oxygen will be 6 times 3, which is 18, plus 4, which is 22. And that's it for that one. So then phosphorus would be next, so we can put a 2 there. Changes that to a 2, changes this to a 6, and changes the oxygen yet again. We've got 18 here, plus 8, So that's 26. All right, so now let's see if we can balance all this out. So over here we've got 8 oxygens. So that means we need 18 from over here. So let's balance the sodiums first, which means I need 6 there. So that changes the sodium to a 6, nitrogen to a 6, and the oxygen to a grand total of 26. And we're balanced.